This is our CS3200 final project presentation. So nowadays, people tend to use multiple video streaming applications, and having to log into different applications to search for a video can often become time-consuming and impractical. So YaTV solves this by organizing the data from these distinct video streaming applications in one place. Now, our system provides a command line interface to interact with the user. It's very nice. It allows the user to perform a series of useful tasks and reports. The user is prompted 3 times. The first prompt asks the user to choose if they want to perform a task or a report. The second prompt asks the user to choose which task or report they want to perform from a list of numbered options. And finally, the third prompt asks the user to enter the necessary information for the system to run the task or report query. The system addresses the problem by providing an interface to interact with YaTV's database. So our system has a variety of features. These can be broken down into tasks and reports. So a few things we can do with tasks: we can register a new user, subscribe a user to an app, add a show to a user's My List, update an app's version on a platform, add a new video with all associated metadata, which is the latest in a show's current season, produce a ranked list in the top 10 most watched shows, each with a corresponding app, find all free videos on a particular platform, find all long videos that were released this year and aren't part of any show, produce a ranked list of revenue generated by apps in a country, and produce a ranked list of watch counts from the top 3 video tags. In addition to all this, we also have several report queries that a user can run, and these are very in-depth. So the first thing they can do is they can generate a summary of all users from a country. So this contains useful information like the user's email, their name, the number of videos they've watched, and the number of apps that the user has seen videos from. Next, we can generate the summary of a video. So this contains useful information such as the number of users that have seen the video, the title of the video, the description of the video, the season of the show that it's from, the show that it's from, the app that it's hosted on, the release date, whether or not it's free, and how long it is. We can also retrieve all videos that belong to a user's My List. We can get the total number of watchable hours from a video on a platform broken down into free content and subscriber-only content. And finally, we can get a summary of information for every app, including the number of shows that are available on that app, the number of videos available on that app, the total number of content available on that app, the number of subscribers on the app, how many platforms the app is available on, and more. So these are all the features of our system.
So for our system architecture, we are using MariaDB for the database management system, as well as XAMPP to create a server running on our local computer. So along with that, since we're running the web server locally, we can go to localhost on a web browser and bring up phpMyAdmin, which allows us to import our DDL and DML to initialize our tables and any input data that we've constructed. And then as far as the application to interact and manipulate the database, we created a command line tool using Java, and this allows us to perform any of the tasks or reports mentioned in the previous slides. And so what our application is actually doing is 2 steps. So the first is getting the user input, and that's selecting which report or task to run, as well as the SQL arguments if it's parameterized, and then constructing the SQL statement. And so our app is using prepared statements for this, and from a security perspective, this is going to prevent things like SQL injections because it's placing the input in a set position. So for the second step after that, we're connecting to the MariaDB database, and then so once that connection is made, it's executing Any SQL that's going to mutate or add additional data is going to be reflected in the actual database. So if it's reading some information, it's going to use this connection, read from the database, and then output that to the console. So this is briefly how each part of our system is interacting, how the different components come together in the final application. So next, focus on the design of our database. The first step in our design was constructing the ERD. So briefly going through which entities we have created. We have user, app, platform, video, show, and season. So for video and show, we've created unique IDs because it could be the case that two videos might have the same title or two shows might have the same title. So those are identified by IDs. User has email, app name, platform name. And the rest of the attributes are pretty straightforward. One thing notable about our design is the user's MyList, which is a derived attribute. So we wanted the user to be able to create a list of both shows and videos, but not necessarily both, so they can have a list of only shows or only videos or any combination. And then our system can go through and combine these to form the iList to perform any queries or anything later on. And then for our relationships, user can subscribe to an app. Apps are on the platform. Apps can host any number of videos, but a video is hosted by one app. And then down here we can see that season is a weak entity utilizing the show ID in addition to the season number.
Alright, so for our relational model, we basically follow the translation steps to go from an ERD to relations that we saw in class. So these are the tables that we created. On the previous slide, we already saw the attributes and the primary keys that relate to each entity. But here we can also notice the few extra tables that were created in the cases where there was a many-to-many relationship. So that's the case for subscribes to, available on, my list show, and my list video. These were all many-to-many relationship cases. Then we also added foreign keys in the cases where there's a many-to-many relationship, so the cases I just mentioned. And we also added a foreign key in the cases where there's a many-to-one relationship. The entity on the many side of the relationship has a foreign key that relates back to the primary key of the other entity in the relationship. Then as far as the source of the data goes, our DML SQL file provides data sets for each table in our database. So the DML is truly our only source of data in this case. And the data sets in the DML provide at least 10 rows of data for each table, such that we can run any report or task and we can get some results back. Then for the physical design, we added indexes for the video title and the show title attributes because of how selected they are. They're not primary keys. We added IDs for a video and for a show, and those are the primary keys. But regardless, they're pretty selective because realistically there wouldn't be too many movies or too many shows or too many episodes with the same name or title. So given that they're very selective, we thought it was a good reason for adding an index for performance reasons. For whenever we're querying, for whenever there's a video title or a show title showing up on the word clause of a query, which is a general case. Then all tables are normalized to third normal form. We didn't denormalize any tables. We didn't find any use for it or any performance benefits in our case, and so we just went with the normalization, which obviously gives us the benefits of minimizing duplicating information, avoiding modification anomalies, and disallowing spurious tuples.